Welcome everyone. In this video, I'll be introducing KNIX microfunctions, which is a high-performance open-source serverless platform that has been designed specifically for low-latency execution of serverless functions and serverless workflows. KNIX offers certain unique features such as support for stateful functions. It has a built-in hierarchical key value store. It is compatible with Amazon Step Functions, and it offers a powerful graphical user interface, SDK, and a CLI. My name is Parijat Aditya. I am one of the developers of the KNIX platform, and I'll start with a simple Hello World example written in Python. Then we'll add a non-standard Python dependency to this function, such as NumPy. Then we will create a workflow with two functions executing in a sequence. Then we'll have these functions executing in parallel. And finally, we'll create an image resizing example where we will use the built-in key value store. So let us start with a simple Hello World example. So functions in KNIX can be written both in Python and Java, and I'll be using Python for this presentation. So each function receives a valid JSON text as input, which is converted into the corresponding Python data type and then given as input. And functions must return a Python data type as the output, which is also converted into the corresponding JSON. Now each function must define a method called handle, which will be invoked by the KNIX runtime environment. And the handle method is given two parameters. First one is called event, which is the actual function input. And the second one is context, which is the API object exposed by KNIX to let you access the built-in key value store and some other functionalities. So in this simple example, we'll print out hello world. In the function, we'll print what is coming as the input. We'll also print the type of that input, and we'll return the input as the output of this function. So next, let us log into the KNIX graphical user interface. And once you do that, you're presented with this dashboard, and here you can see the version number as well. So let's move on to the functions tab, and I'll add a function called hello, and I'll click save, and it opens up the code editor dialog box where I can type out the function code, or we can even upload some function code. But I'm gonna just simply copy paste some code here. I'll save changes, close. And if I want to quickly test this function out, I can simply press test here. And now this function code is being deployed on the KNIX infrastructure. And once this deployment is finished, it will open an execution dialog box where I can provide the input to this function. So once the execution dialog box opens up, you can give the input at the top. So let me give the valid JSON text as input. So this is a list. I press execute, and at the bottom I can quickly see a timeline of the function execution. And if I hover over it, it shows me the log output from this function, which I can also see if I click the execution log tab. And here I can see that we printed hello world. We received a list object as the input, and which contained 10 here, and we can see the execution output, which is simply the input returned as the output. And if I now pass a different JSON text, let's say a string, and press execute, then we can see that what was returned out to the function was a string object. So in this simple example, I have shown you how to create a simple hello world function. I showed you what is the input and output to this function, and the code editor window, how you can edit this function and quickly test this function out. So next we will create a function that would like to import a non-standard Python dependency such as NumPy, which is not part of the standard Python distribution. And in this example, I will also introduce the concept of a workflow and how to invoke them. So I will create a workflow with one function, which is called random, taking integer as an input, and then it will create those many random float values using NumPy, print them, and also return those values as a list. So let us go back to our graphical user interface, and here I will create a function called random, and I'm gonna simply copy paste some code here, and then I save changes. And to specify NumPy as a dependency, I go to this requirements tab and I simply type numpy, and this is essentially a pip installable dependency specified as a requirements.txt file which pip uses. So I save changes, close, and I'm not going to press the test button here, but instead I'm going to create a workflow because everything in KNIX is deployed as a workflow. So I'm going to explicitly create a workflow for this function, and it's called random, and of course the name doesn't have to be the same as the function. And I click save, and then it opens up a workflow editor dialog box, and it is showing you a template description for this workflow, which is essentially JSON, and we follow the Amazon States language description format here. So the Amazon States language lets you describe a state machine which has a bunch of states, and the execution flow moves from one state to another. So, and each state essentially encapsulates a function or different kind of an execution modality. So the first thing you specify is the state in which your state machine will begin, and then you specify which all states exist in this state machine. So there is only one. And the next you specify which function is this state encapsulating. And since there is only one function, I will set end as true. So I save changes, and it has immediately identified that the random function is part of this workflow. And if you visualize it, then it nicely shows you the workflow description as these diagrams. So I save changes, I close, and then I deploy. And pressing the deploy button is essentially doing the same thing as when we press the test button with the function. It takes the workflow description that we have created. It is now instantiating resources on the KNIX infrastructure. All the pip installable dependencies for these functions are also being added along with this function, and the workflow will, along with the function, will get deployed. So once the workflow is deployed, I can press this execution button, which will open up this dialog box, the same as before, where we provide the JSON text as an input to your workflow, which is essentially the input to the first function of your workflow. So in this case, it is going to be an integer. So let's say I put 10 here, I press execute, and then this workflow will get executed, and the timeline for that workflow execution is presented. So the random function got executed. I go to the logs, and I can see that there were 10 float values that are printed because that's what we had, and those are also being returned as the function output. And I can also look at the execution path, which also shows you how the workflow execution moved from which state to which one. So this was an example of how I can execute the workflow using the graphical user interface, but I can also do the same using this generated URL. And I'm going to open up a shell dialog box here. So I'm going to use a curl statement to execute this URL. And I'm going to copy this thing out here. And this is essentially just a post statement, post command that I'm sending out. And the data that I'm sending, which is the input, is just 3. So 3 float values should be generated. And there it is. So you have the return values as the 3 float values that were generated. So in this example, I have showed you how you can create a function which uses a non-standard Python dependency, and how you specify that using the requirements.txt. I showed you what is a workflow and how you can invoke it using the user interface as well as the URL. So next we will create a bit more complex workflow with 2 functions in it, and we'll make it such that the output of the first function becomes the input to the second one. So our first function is random, which we defined before, taking integer as an input, returning a list of floats. And the second function will be average, which will compute the average of these values, print them, and also return it. So let us go back to our user interface. First, I will add a function called average, and I'm going to simply get some code for that here. Paste this, save it, and I close it. So next I will create a new workflow called toStates, and I will add both these functions to it. So let me first recreate the description format for the single state workflow, which was this. And then I'm going to copy out this little section here and duplicate this, and I'm going to call this new state average, and it is going to encapsulate a function called average, and this is going to be the end state, so end is true. And what I'll do next is that instead of this end here, I will change it to next, and I will set that the next state to execute after random is going to be average. And I save changes, and it has identified both these functions. And to check if everything is correct, you can look at this nice visualization that the flow is right. So I close this and then I deploy it. So now both these functions are being packaged together and then deployed on the KNIX infrastructure. And once the deployment is finished, as before, I can click the execution dialog box, and I'm going to give an integer as an input because that's the input the first function expects, and I press execute, and this time I should see the timeline containing two functions. I can zoom out a bit, and here I can see random was executed and then average, and then I click execution log. So here I can see first the random function was executed, printing out 10 values, and then the average function was executed, printing out 1 value. And this number here represents the execution ID. So every time you execute a workflow, this ID keeps changing so that you can differentiate different execute. And if you look at the execution output, then it shows the output of the last function of this workflow, which was average. And the execution path will also show how the execution moved from one state to another. So in this example, we created a bit more complex workflow with two functions, and I showed you how you can define both of these functions in a workflow description, how they get connected, and then how we execute them. Next, we will create a workflow where functions can execute in parallel. And for that, we will use the parallel state of the Amazon States language, which KNIX supports. So the input to this workflow are going to be two integers given as a list. The workflow will contain two states. First is a parallel state called fun with math, followed by a task state called after. The parallel state will contain two branches. The first one called subtract, which will simply subtract the two integers and sleep for a while. And the other branch will contain a function called add, which will add the two integers. And once both these branches are finished, KNIX will accumulate the output from both into a list and only then invoke the after state. So let us go to our user interface and start adding these functions. So I'm going to create the add function, and this time I'm going to upload it as a Python file. I save changes, and I'll be able to see the code for this add function. And I'll pause the video and I'll resume when both the other states are, the functions are uploaded. Now all three functions are uploaded, and next I'm going to create a workflow to have all of these into a workflow with parallel state in it. So let's name it parallel workflow. And I'm going to copy paste a description, and essentially in this description I have defined two states. First, fun with math, which is of type parallel, and the next state of that state is after, which is a task state, which is pointing to a function called hello. And within the parallel state there are going to be two branches. Each branch is a state machine, a complete state machine on its own, which contains just one state right now. So the first branch contains a state machine with one state called add, and the second one with subtract, and then they are pointing to the corresponding functions. So I save that, and I can look at the visualization to see if everything is correct, and I close it, and then I'll deploy this. So now all of these functions are being packaged together and then deployed into a workflow on the KNIX infrastructure. So now the workflow is deployed. So I will click execute to open up the execution dialog box, and I will give the input as two integers as a list, and I'll go to the execution log and I'll click execute, and then we'll watch the logs that are produced So first we can see that the add and subtract function have run, but not to completion. The subtract function is still in the sleep state, and after that sleep is finished, it prints the one remaining output, and only when both these functions are finished, the after state is invoked with the list, which corresponds to the output of both these branches. And we can see the execution output, which is again the same output of the after state. If we look at the execution timeline, then the same picture is depicted. So here is the add state, the subtract state, which took 8 seconds, and then after that the after state is executed, which is also shown in this execution part. So in this example, I have shown you how you can create a complex workflow where functions can execute in parallel, and how you define the workflow description for that and execute it. So in this final example, we'll create a function which will take a JPEG image as input as base64 encoded, and then it will resize it to half its size, and then write the resized image into KNIX's built-in key value store. And in this example, I will also show you how you can package a custom dependency for your function as a zip file and then upload that. So let us first look at the code for the resize function, and I'll be using the Python imaging library for resizing. This is pip installable, but for this example, I will manually download it along with the function and then zip it. So the code for this resize function is straightforward. It receives the encoded file as input. It will base64 decode it. It will use the imaging library to resize it into a buffer. And then it will use the context object, which is received as a second parameter, and use the put API to access the key value store to write this resized image. So the key is going to be the name of the resized file, and the value is going to be a base64 encoded resized image buffer. And then finally, I will return the name of the resized file as the output of this function. So what I want to do next is that I want to download this Python imaging library and keep it right next to our resize image function. So if I look at that, I have the resize.py file, and I want to pip install it with this -t parameter, which says that please install it in the current folder. But I'm going to actually do that inside a Python 3.6 Docker container so that I can get the Python version right. And the current folder is mounted inside this Docker container. So now this container will execute, and it will download the imaging library. And then once it does that, let's look at this. So 3 new folders have been created, and they are kept right next to the resize.py file. So next, I am going to zip the contents of this folder and create a zip file outside this folder. So if I now go one level up, you can see that resize.zip has been created, and this is the complete package containing your function and the Python imaging library that was downloaded separately as a custom dependency, and which is what we will use to upload in KNIX. And this is very similar to how Amazon Lambda also lets you create zip packages. So now we'll go back to our user interface, and we'll create a function called resize. And then we'll upload the zip file that we have created. And once this zip file is uploaded, it will unzip this file to show you the contents of the file so that you can inspect it. And you can also inspect the resize.py code that is part of the zip file. So the zip is uploaded. I can inspect the Python code, which is the resize image code. And now I'm going to create a workflow, which is also called resize. And this is going to be a very simple workflow with just one state in it called resize, pointing to the function resize and starting at resize. Save this, close this, and I'm going to deploy this. So now the zip file that we uploaded is being deployed as part of the workflow, and it is being unzipped. The custom dependency is being installed, and it's instantiated on the KNIX infrastructure. So the workflow is now deployed, But we are not going to execute this workflow using the execution dialog box, but instead we'll copy this URL and then we'll use a custom Python script which uses the Python requests library to make a post request. So I'm going to first replace this URL. And this script is essentially taking a JPEG file as the input parameter, base64 encoding it, creating the appropriate Python dictionary, and then sending it as a post request. So let us use that. Let us first see. So here is our request.py, and I'm going to use this leaves.jpg, which is already available. So this file is this leaves.jpg file. So now I'm going to say Python 3 requests, and then I would say leaves.jpg. And once I execute it, I receive a 200 OK, which means that the workflow was correctly executed, and we see the name of the resized file. So I'm going to go back to the user interface, and the resized file is going to be available in our object store, and I can now download this, and I'll simply place this file right next to the leaves.jpg file, and I'm going to inspect this file now. So here is the leaves file, and this is the resized file, and I'll open this so that I can check this. So this is the original file with the 1500 pixels as the length, and this is the resized file, which is the half-sized file, 750. So in this example, I showed you how you can create a function with your custom dependency packaged into a zip file. And I also showed you, using this resize imaging example, how you can access the KNIX's built-in key value store. So with this, we come to the end of our KNIX's general tutorial. Thank you for watching, and you can find more information on our GitHub repository or contact us on our Slack channel. Thank you.